As cognitive psychologists, we're often interested in the underlying causes or mechanisms of our thoughts, knowledge, and decisions. However, these underlying causes are not directly observable, so we assume that observable measures, such as response time and accuracy, are manifestations of the underlying factors that we are interested in. This can be a serious issue because the mapping or transformation from the unobservable to the observable is almost always unknown. It's unlikely that these transformations are linear, but the way we interpret many of our analyses imply the assumption of such a linear transformation. It's easy to intuit that the relationship between two variables is linear when it's not. For example, imagine you're trying to drive to a destination as quickly as possible. What happens to your total travel time when you increase your speed from 40 to 50 km per hour compared to 60 to 70 km per hour? While the increase in speed is the same in both cases, increasing your speed from 40 to 50 km per hour has a greater effect on your total time traveled than if you increase your speed from 60 to 70 km per hour. It is very intuitive to interpret observable variables as linearly transforming to their underlying causes, but doing so would not necessarily be accurate. For example, if you had a Likert scale measuring preference of ice cream, my rating of strawberry ice cream as a 10 and my rating of vanilla ice cream as a 5 doesn't mean that my liking is truly twice as much for strawberry compared to vanilla. Similarly, if we observe a decrease in reaction time from 200 to 100 milliseconds, that could easily imply a greater difference in mental processes than a decrease from 1000 to 900 milliseconds. The issues we have raised so far often lead to us interpreting the meaning of interactions incorrectly and making conclusions that our data cannot support. If there's no interaction, we may be quick to assume that two processes function independently to one another. But if there is an interaction, we can be equally quick to assume that one factor has moderating effects on another. However, many interactions can be transformed into significance or not if we apply a nonlinear transformation to the observed variable. For example, imagine that you conducted an experiment with younger and older adults, and your participants completed a lexical decision task where they decide if an item is a word or a non-word. You also include a manipulation of stimulus degradation, whether a word is intact or degraded. Imagine you do observe an interaction in reaction time, so you conclude that older adults are more affected by the degraded stimulus. However, this interpretation would be too hasty. Even though reaction time is what we observe, we're interested in the underlying processes leading to reaction time as an outcome. A leading formal account of how reaction times are generated is the diffusion model. According to this model, reaction times are a result of a decision-making process, where information is gradually accumulated until a threshold is reached, and then the decision is made. In this model, drift rate is the parameter that determines how quickly information is accumulated. So while the observed reaction time is a result of drift rate, the relationship is not linear. If we apply the model's transformation so that our dependent variable becomes drift rate, the interaction between age and stimulus degradation disappears. This can also go the other way. What seems like a non-significant interaction can be transformed into a significant interaction if we apply a nonlinear transformation to the observed variable. Even if the drift rate model is wrong, it is arguably more wrong to assume a linear relation between reaction time and our hypothesized mental process. Of course, this is only an issue when we want to make claims about the underlying unobserved processes. Sometimes we really are only interested in making claims about the observed variables. For example, imagine you're an analyst studying online buying behavior. It's likely that you're interested in what affects how much people buy and not so much about internal mental processes. But as psychologists, we are usually interested in the underlying mental processes behind measurable behaviors. We aren't really interested in studying responses on Likert scales or reaction times. We're using them as a proxy for mental processes that we can never observe directly. The problem is when we assume that the relationships between observable and unobservable measures are linear, when they are unlikely to be. There are ways we can both strengthen our conclusions and help to prevent any potentially false conclusions from the interactions or lack of interactions in our results. We can check if the interaction or lack of interaction is robust across different reasonable, nonlinear transformations of the observed variables. For example, if you are a memory researcher, your dependent variable may be proportion correct. You can transform this using the logit function. Or, if you're interested in reaction time, you can apply the logarithmic transformation. Finding the same pattern across a wide range of transformations increases your confidence in the robustness of your conclusions. Another strategy is to check if your interaction or lack of interaction is robust across different subsets of the data, across the scale of the dependent variable. For example, you can divide your data into low, medium, and high-performing individuals and see if a consistent pattern of data emerges across subsets. Finding the same pattern across the groups can increase your confidence in the robustness of your conclusions. While it's critical that we understand the potential problems in assuming a linear transformation between behavior and mechanism, there are ways to increase our confidence in our results and the claims they support. This is important in the fields of cognitive science and psychology, but also in any field that interprets statistical interactions to draw conclusions. And with this knowledge, you are now more equipped than ever to interpret your research findings.